color Mlue, or the Reactive JavaScript turtle. Today we are going live to talk a little bit about a program called Mlue. You know turtles, right? They have a shell on the outside. Well, they're actually turned inside out. And that's what we have done here. We have turned reactive programming data structures inside out. What does that mean? Usually when you have a data structure, such as a spicy list of objects where you want to keep track of changes to that list, which is weirdly complex, then you need to create a special wrapper for an existing list object. Doubly linked list is my favorite, but normally people just wrap arrays, the simplest list object that has a really decent splice function that will take care of all your needs. It asks you where you want to put a thing, if there is anything you want to delete there, and for the very thing that you will be inserting into the list. That's a pretty nice setup. You also have pop push and shift unshift to add things in the beginning or the end, or top or bottom of the array. Reactive programmers sometimes implement their own pop, push, unshift, and splice, and reverse and sort. Sometimes they do a pass-through with a proxy. Or sometimes they get really fancy and go wild. This is what I did yesterday. I went super fancy, performing extra research for an AI-generated live array that reports changes. It is a large program, it is a heavy program, and when time came to use it, even though I know it is pretty perfect, I didn't like the idea. I don't want to put a heavy reactive array into my lightweight tree that is supposed to work fast. So, I sat down in front of my computer after I returned from the gym and started thinking. Recently, I've read an article that if you want to study a system, learn about it and then take one thing away to watch what gets broken or what changes so that you can study the system in more depth. I don't think that's correct at all, but the one thing well does hold water. You just need to do the reverse. You have to add one little thing. That means you're adding lightweight and tiny little thing to a very complex system, and then you study how much you got out of it, if it was worth it, if you can build a top. Since nobody ever needs a plain reactive array, since it's always part of some system that keeps track of some list somewhere, reactive arrays are weird and I think perhaps maybe a little useless. So, what is it that we need, I ask myself. And I figured, I'll start with an OOP tutorial because I'm kind of doing this to teach JavaScript. So I went looking at tutorials and I found someone talking about a rectangle. Just about the simplest object you can have. It has a width and a height and then some extra functions like getArea. So I took that and I told myself, what if I can track changes to this thing by just giving it a revision number or a version number? And that sounded really well to me. So it would be width, height, and version. Now, I have the ability to make the version reactive because I like signals. I'm a big fan, actually. So if I create a dis.rev, short for revision, signal, and I start at revision 0, I create a feature where other parts of the program can listen to the rev signal. And when it changes, they will be notified. And here, they will take the object that the rev belongs to, rect1 for example, and do something with it, recalculate something. Well, that's pretty good, I thought, since the whole point is to track changes to an object. But we have a problem, because when someone changes the width or height, you have to manually say rect1.rev.inc, short for increment. And then, and only then, will others hear of the changes. All right, I said to myself, and I turned to my trusty AI that sits by my side here, and I said, hey, create a watch function for me. Let it accept the object it needs to watch, the properties it should check, and then a little function that it will run when any of these are changed. The little function is, of course, this.rev.inc. And the whole point of this is to create a watcher that detects when someone tries to change width or height, or even run a special, somewhat questionable method that I called resize by, and then give it a scale factor, so resize by 2, for example. This is usually where things get weird. This is usually where you get knocked down and taught not to invent. Because resize by is being monitored by the watcher, that's good. But so is this width and this height. Yeah. So now resize by will trigger, this.width will trigger, and this.height will trigger. And that will create a mess, sometimes an infinite loop even, in some cases. So, already, because we created a watcher that watches a function that does some resizing of properties that we are already watching, it's a total failure. But, of course, I thought about all this ahead of time, and I replaced a plain old signal with a specially crafted signal-like revision object that uses a set and then a queue microstack to run things only once. Even if you say something many times, it only gets executed once because you're saying the same thing. So, the watcher was still valid because I set up a queue to run the functions later. Queue microtask is very similar to request animation frame. All this strangely named wonder does is run your function later, when JavaScript is ready. Not now. Don't count on it at all, but later, right before the other stuff runs. That's a pretty good deal. So we know it's gonna run at the end, and we can pile up a bunch of stuff in there, and since it's a queue based on a set, only one thing will stick. A set only allows one instance of a thing you are adding. This is not why I added queue microtask, but it was already there solving the method and property problem where we are changing a thing from within a thing that's already changing a thing. Good, it worked. I added queue microtask because we are dealing here with stuff that usually gets rendered on the screen. So we don't want to refresh some part of the user interface as many times as some value changes, just once, at the very end. Oh yes. It is okay to change things from within a thing that is being observed, and we are going to have efficient updates on the screen because things are only going to render once. This rectangle is as generic of an object as it gets. It could be user, it could be button, it could be any class that you are working on. And because we have a rev property from the revision system and a watcher that can automatically report when to increase revision based on the things that get changed or executed, we have a generic reactive system. It is a turtle because we don't have a rectangle that extends a reactive object. We just have a normal rectangle on top of which you bolted on .rev that things can listen to, and the watcher, which will monitor when you access with height and resize by. Those two things make a reactive system. This is an invitation, of course. Any object you find in JavaScript tutorials can be made reactive by giving it rev and then setting up that the constructor returns the watcher with the members, which is to say methods and properties, that you will monitor and then run the rev.inc or increment. So we've done well, but reality is such that once you start using this brilliant little thing, it will get you again. And such was the case here. I created rect1, new rectangle 5,8, and rect2, new rectangle 6,7. We still have full functionality over the object. We did not modify it in any weird way. So we can use a static function, which is like a utility program related to rectangle, and we can say console log rectangle.compareArea rect1 rect2. And this will absolutely work because we aren't changing anything. We are just reading rect1 and rect2, which under compareArea runs the getArea method, which then accesses this width and this height and multiplies the two values. So there's nothing weird here, it's just normal programming. The watcher did return from the constructor, so we are using a proxy, but it's a transparent proxy that no one can see, basically. Here you see the whole point of reactive programming. Because now, if we were to say rect1.width equals 50, we would still see the old value on the screen, the compareArea result. It would just never update because it already ran, it already calculated. But in the world of reactive programming, when you change a value, or increment the .rev directly, things will rerun. Above all, when you subscribe to a reactive thing, you will be given an unsubscription function. This is a kind of a new way of doing things. And when you want to stop rerunning the function when things change, you execute that function. It's as simple as that. It contains all the stuff inside to make everything stop. Now, even though we have this beautiful revision signal style thing, and we created a watcher, we are still missing parts. Because what makes a lot of sense is to watch both of the rectangles at the same time, so that if one of them changes, you will be notified. For that, we need to use a combine latest function. It appears now and then in reactive libraries. If you keep an eye on things, you will discover it frequently enough to know what it is. And combine latest, in our case, just subscribes to both of the revisions, one from rectangle 1 and one from rectangle 2, and then returns a signal this time. So we are introducing one more concept, but the signal behaves the same way as rev in that it has a value and a subscribe. So now that combine the latest hooked into rect1.rev.subscribe and rect2.rev.subscribe and created a signal to which these values will be applied, returning that signal to us, we run the .subscribe function on it. And now, whenever rect1 rev or rect2 rev changes, the function we gave to subscribe will be executed. And we can just say the same thing as above, although this time it will be reran all the time. Console log rectangle.compareArea rect1 rect2, which again accesses getArea on a rectangle, and then getArea reads this.width times this.height and returns the area, the number. This will run initially because that's how signals behave, so that whether things changed or not, you get your values and can already display them on screen. But more importantly, the subscribe will rerun the console log function that compares the area between the two whenever you change the dot height on either of the rectangles or manually increment the revision number. Please don't worry. This rectangle workflow where we are changing values and waiting for combine the latest to create a signal that we can then subscribe to, this whole rectangle thing that includes .rev, new revision, and return watcher.watch from constructor is just 22 lines of code. This is something you can totally understand, even though it's just about the hardest thing you will face in JavaScript. The revision object is just about 80 lines of code, and all it is a plain old signal slightly modified to automatically increase the revision and generate a UUID number. The UUID is used in multi-user programming, and I'll explain that in the end. The watcher is 50 lines of code, and it can probably do well at 30 or so. I provide a small signals library specifically to run that example. The combine latest is 9 lines of code. Now let me explain to you very quickly why rev is not just a number, why it is in fact a number followed by a bunch of gibberish. If people using the same program, perhaps based on Mlue, get disconnected from their network or the internet and lose connection with each other, where they can talk to the latest version of an object and instead retain the old revision number. When they make a change and go from the old revision of 5 to the new revision of 6, they will override each other, right? The UUID number prevents that from happening, or the random string of gibberish prevents that from happening, because even though they are at the same revision number, there is that random string of letters that sets the revisions apart. You can save this to disk under a unique file name, just whatever you're working on, .revision-uuid.json. Or you can store it in a database, relying on the UUID being unique and never repeating because it is such a large gibberish number. And then your program can recognize that 2 revisions of the same number cause a conflict, and someone, a human or AI, can be called in to figure out which data is better and what to move to the winning record. The winning record is selected based on the random gibberish number. It is simply sorted from A to Z. The gibberish that comes up on top wins. If you have 10,000 users working on an object that has a revision and they all start losing connectivity in crazy ways but still have to work, so as long as everyone has the full copy of all revisions, things will sort themselves out. Always the same winner will be selected. This is called eventual consistency. It's a pretty fancy thing. That's all there is to it. In closing, this is really confusing and very complicated. But it being a turtle can turn any object you're working with, no matter if you are just starting programming JavaScript or are in fact a seasoned professional working with maybe document object model, it can turn it reactive. You just tell it what properties to watch. This is an optional feature. And then use the .rev somewhere where you can always subscribe to it and then rerun your updates, which will again run extremely efficiently, just once, when everything gets done a little bit later. One of the tests I provide runs .inc or .increment on rev 10 times in a row, which would cause 10 updates of the user interface on your web page normally. But because the system is optimized with a scheduler, it only registers one run. It only runs once. This is very fancy for something so tiny, indeed. And that's it for today's gibberish lesson on JavaScript. It is a brilliant little program that pulls out the two critical components of a reactive object and it gives them to you. And water is optional, you don't have to use it. So you can stick it into any object that you are learning with to make it reactive. That's a big deal. JavaScript is wonderful, but reactive JavaScript makes you powerful.